NASA is sending the OSIRIS-REx spacecraft to explore near-Earth asteroid Bennu. To carry out its mission, OSIRIS-REx is equipped with a suite of remote sensing instruments, including a spectrometer called OVIRS.
OSIRIS-REx is a mission to bring a sample back from an asteroid. That's not something that we've done before, and that's very exciting.
The idea behind OSIRIS-REx is to go to a pristine building block of the solar system to try to find out more about how they formed and to bring a sample back here to Earth.
OSIRIS-REx's primary science goal is to grab a sample of asteroid Bennu and return it to Earth for analysis.
Planetary scientists are interested in asteroids because they're chemistry sets representing the formation of the solar system. You can't learn that on Earth because the Earth has erosion and other processes that have changed its pristine condition.
Asteroid Bennu is interesting because it's one of the blackest objects in the solar system, so we think it's covered with carbon material, organics, the building blocks of life.
To search for organics on Bennu, a team at NASA's Goddard Space Flight Center built the OSIRIS-REx Visible and Infrared Spectrometer, or OVIRS.
OVIRS is a spectrometer. What that means is it breaks down light into a lot of little individual wavelength packets. When you look at very fine detail from spectra, you can tell what the material is that you're looking at, and that's what we're excited about. The idea of going out and looking at something and saying, oh, I know what that's made of, and that would be a good place to take a sample.
Before arriving at asteroid Bennu, OVIRS will have to survive 2 years in the unforgiving conditions of space. Fixing a broken part after launch is not an option, so OVIRS has a uniquely durable design.
OVIRS is a very simple instrument. It has 2 mirrors and no moving parts. And the reason we like that kind of design is because moving parts are one of the things we worry about breaking in space. And once it breaks, your instrument is lost.
The instrument has to operate in a very harsh environment. There is no air in space, there's a high vacuum, things can heat up. Well, if you can eliminate moving parts, that's just one more risk that you don't have to worry about. I don't have to worry about, oh, is that shutter open or closed, or is that motor moving? So we very specifically try to get rid of things that can fail and fail in a bad way.
Designing instruments to survive in space is critical, but just getting there can be a bumpy ride. Rockets shake their payloads during launch, so instruments like OVIRS must pass a vibration test to prove that they are launch-worthy.
It is the test that I hate the most in the world. You've spent 5 years making this nice little beautiful thing and you hand it to somebody and say, try to break it.
So one of the things we do in vibration testing is we'll shake it as hard as we think it's going to see, plus a little bit more, in every possible direction, just to make sure nothing is going to break off during launch.
On OVIRS, we actually had a case where the glue came a bit apart during thermal testing, and then when we put it on the vibration chamber, a full assembly gave way and there was a big pulse on the instrument. We had to stop and go back and make sure that everything was fine, which it was. We also had to redesign things a little bit, and that shows you the value of testing. Had that been on the launch chamber, we wouldn't have been able to do anything about it.
OSIRIS-REx is a cutting-edge mission to explore asteroid Bennu and the origins of our solar system, and OVIRS is critical to the mission's success.
OSIRIS-REx is just such an interesting mission. The concept of going to one of these really primitive bodies and bringing back a sample that we can then study here in the Earth is pretty spectacular when you think about it. From the OVIRS instrument itself, I'm actually quite excited to see if we can see organics on the surface and what interesting minerals we actually do find, because we won't know that until we get there.
We've got a very good instrument complement on top of a mission that's taking a sample. So we can tell what we're taking samples of, we understand the context of the sample that's returned, and the sample, when it comes back, will be analyzed by people all over the world for the next 40 years. So it's just this very nice, complete package.